2345 1 to 345 12 3 to 5 12 to 45. This alerts us to the fact that the point, line, triangle, and tetrahedron are also described by the coefficients of equations of lower degrees. This build-up of numbers is known as Pascal's triangle. 1 equals c plus 1, 0 equals 1 1.12 1 equals u plus 1, 2 equals 1 2 1 2 points. Leg 1331 equals, a, plus 1, 3 equals 1331 3 points, 3 edges, 1 face 14641 equals a plus l, asterisk equals 14641 4 points, 6 edges, 4 faces. The correlation of coefficients to vertices, edges, etc., emphasizes the more abstract significance of these figures, and in addition, provides us with a quick way of knowing the number of edges, faces, etc., which becomes difficult for the higher figures. What can we call these figures? Polyhedron, which means many-sided, is not the right word, since we would like to include the triangle, the line, and the point, which have no sides. But all the figures have vertices, so we may call them polyvertons. The figure having 5 vertices becomes, then, the pentaverton. We noted that it could not be constructed in 3 dimensions without stretching one line. But since a stretched diagonal is an internal stress which implies storage of energy, we may correlate the pentaverton with the 5th kingdom, plants, for this is what the plant is able to do. So we now say a seed is a 4-dimensional object, or 5-dimensional if we have the 0th dimension. This promises to remove higher dimensions from their usual employment, which is impossible to visualize. We now have given concrete confirmation, for we can see a seed. It externally resembles any other solid object, say a pebble, but it contains an internal organization having the power to store and expend energy. Joining 6 points gives us the hexaverton. It has some resemblances to an octahedron, since it has 8 exposed sides, each one an equilateral triangle. However, when we join all points we get 15 edges. How many faces? The formula gives 1 6 15 20 15 6 1, so there must be 20 faces and 15 tetrahedrons. See if you can find them. Here we must have 3 internal diagonals asterisk each one stretched. This hexaverton correlates to the animal kingdom. The 3 stretched diagonals suggest the animal's power to change its shape by stretching in different directions, which is the basis for animal motion. A further property of this model is interesting. Its description takes us back to mapping or its equivalent, joining points on a surface. How may we join 6 points with lines that do not touch? This cannot be done on a plane surface, which is inadequate for more than 4 points. However, it can be done on a Mobius strip. Mobius strip *I_6, 5 to 4, 3 to 2. The tracing of the figure is facilitated by the convention of showing a Mobius strip as a square and remembering that the opposite edges join in an inverted fashion. BD, note that the edge joins DC so that B touches C and A touches D. The right edge of the square is pictured as going around the back, twisting 1/2 a turn, and joining the left. This twist makes it possible to join each of the 5 points to every other point. The 6th point at the center is joined to all 5 which surround it. Note that each point has 5 lines leaving it. This seems quite different from mapping, but it is really the same problem. A map on the Mobius strip can be made which requires 6 colors asterisk the heptareton connecting 7 points each to each requires 21 hnes or edges. Starting with 1, we draw lines to the remaining 6. We then join 2 to 5 more. It is already joined to 1, and 3 to 4 more, and so on. So we have 6 plus 5 plus 4 plus 3 plus 2 plus 1 equals 21. We can confirm this from the coefficients, which are 1, 7, 21, 35, 35, 21, 7, 1 asterisk contrasted to the 7 required on a torus, as we pointed out earlier in this appendix. This figure can be thought of as adding a point at the center of the octahedron, and this additional point creates a set of 6 compressed diagonals in addition to the 15 edges of the hexaverton, making 21. That this figure is the equivalent of the 7-color map is evident from the fact that 7 points may be connected each to each on the surface of a torus with no intersections. The demonstration is similar to that for the hexaverton on the Mobius strip, except that we now represent the torus as a plane whose opposite edges are imagined to curve around and join, top to bottom and right to left. Here there is no twist, but both pairs of edges join. IO VVV2 to 62 to 62 to 7, RF dash 2 dash 72 to 31 H2 to 31 slash YCV M Y 5 to 3 S1 // X I / 5 to 6 I dash 5 to 6 dash at 1 to 6 slash F1 1 to 6 Joe VFVVB. To what is most interesting is that with the heptaverton we have the maximum possible number of triangles around each vertex. The tetraverton has 3, the pentaverton 4, the hexaverton 5. Since in the heptaverton each point connects with 6 others, the 6 resulting equilateral triangles fill up the 360 degrees of space available in a plane. This suggests we can go no further. A quite interesting paradox is suggested by the fact that space would be filled by the heptaverton. Suppose we were to make a heptaverton model of the universe. We would find that the interface between the model and the universe extended infinitely in all directions. And we would not know whether we were inside or outside the model. While the vertons beyond the tetraverton, 4 points, are not possible in 3 dimensions of ordinary space and require the addition of imaginary dimensions, it would appear that joining more than 7 points is impossible even with imaginary space. This is given some credence by the progression we have encountered, first 1, 2, and 3 real dimensions, then 1, 2, and 3 imaginary dimensions. Counting the zero-dimensionality of the point, we have 7 dimensions, and if these are all that are possible, we confirm the 7-fold nature of process. 7 postulates compared to 7 points. It is interesting that the problem of joining 7 points each to each is in some respects equivalent to the postulates of projective geometry mentioned earlier in this appendix. Veblen and Young show that the postulates imply that there are precisely 7 elements or points in S, the totality, and that there are 7 classes each of which contains 3 elements. They illustrate this by posing the problem of creating 7 3-man committees from 7 men, the committees to be chosen in such a way that no 2 persons are together in more than one committee. Postulate 2. If the 7 men are A, B, C, D, E, F, G, we may select the committees by taking A, B, and D for the first committee, B, C, and E for the second, and soon. A B C D E F G A B D B C E C D F D E G E F A F G B G A C. This can be shown for the 7 points of the heptaverton. Thus, there are 7 triangles, each of which contains 3 points, such that no 2 points are in more than one triangle, or no 2 triangles share an edge. The 7 triangles use up all 21 edges of the heptaverton. The classes of the postulates are thus faces, each one determined by 3 points. We can also show that there are 7 tetrahedrons with no face in common. Veblen and Young prove that if 2 universes Si and S2 satisfy the 7 postulates, in that their elements and classes correspond, then Si and S2 are abstractly equivalent, and constitute the same universe. They entitle the set of postulates which lead to such isomorphic examples categorical. We have shown that the heptaverton is 1. Isomorphic with the torus, in that the connections of 7 points with lines which do not cross is equivalent to mapping 7 countries. This is also stated by Hilbert. * 2. Isomorphic with the 7 postulates, in that both their elements, points, and classes, triangles, can be placed in correspondence. Therefore, since both the torus and the 7 postulates are isomorphic to the heptaverton, they are isomorphic to each other. We could therefore conclude that the 7 postulates require a toroidal universe. However, this is not our goal. We want to show that the 7 powers, as charted on our grid, are isomorphic to the torus, and this requires that the powers be isomorphic to the postulates. It should be sufficient to show that the powers can be assigned in one carat and only one way to the postulates. Since the powers are cumulative, they have a necessary order, which of course is that of the kingdoms of nature. We have shown that when the postulates are placed in the order shown on page 268, they correspond to the powers, and preserve the same symmetries. This ordering placed the postulates at least on the left, what comes first, and no more than on the right, what follows. This is necessary since we cannot limit the membership until it has been filled. The ordering also places postulate 4, there exists at least one class, first. This is the only postulate that could come first, because it establishes existence. Postulate I must follow because it distinguishes 2 things, and V must come third because it deals in 3. The ordering of the last 3 is determined by the symmetry. We can thus conclude that the powers have the property of the postulates, and are categorical. Moreover, it follows that any imiverse, by which we imply any process, must imply the same powers. Here we must recognize that the description of the powers is subject to considerable flexibility. In a sense, the powers are undefined terms. In another sense, they are not. Their proper definition requires only that, 1. They be independent and categorically distinct. 2. They be cumulative, which implies a definite order. Hilbert, D., and Cohn-Vossen, S. Geometry and the Imagination. New York, Chelsea Publishing Co., 1956. These requirements can also be met by distinctions based on dimensionality, i.e., oneness, two-ness, etc., which, it will be appreciated, imply degrees of freedom and hence levels, as in the arc. We are thus equipped with a paradigm that can be enforced as a categorical principle. The reader is likely to object and say that this violates the principles of valid inquiry, which should be based on the inductive method. But this misses the whole point of our method. A true scientific inquiry must be based on some paradigm, and if this is not recognized, the paradigm remains unconscious. Such is the fourfold paradigm which structures objective science and leads to determinism. It is false because it overlooks first cause and makes rationality the final arbiter. Its emphasis on objectivity omits the projective aspect and leads to a cul-de-sac. It fails to discover the reflexive quality of the universe. The sevenfold paradigm corrects these errors and opens the closed system that the fourfold would dictate. It frees us from a misinterpretation of the constraint of law. Approaching a subject with the sevenfold paradigm can be compared to approaching a machine with the knowledge that, in addition to its structure, it has a purpose and can be turned on, whereas the objective paradigm would permit only a study of its structure. Importance of the committees. The committees, or subsets of 3 points, are important because they meet the requirements of the postulates of Veblen and Young. We have shown that the postulates can have a correspondence to the 7 kingdoms. We are entitled to extend this correspondence and ask, K. The postulates correspond to the kingdoms, what do the committees correspond to? Clearly, the committees must be interactions between kingdoms, or perhaps better between the powers of kingdoms. But my effort to discover such correspondence was not successful until I discovered that the committees could be constructed in a different way from the one already shown. For example, instead of the connection in Fig. 1, we may connect the points as in Fig. 2 Fig.L Fig. 2. Note one point has been moved inside, making possible 3 narrow triangles, but this was still not fruitful. What did prove fruitful was to recognize that the formation of committees is cumulative. As the number of elements increases, the number of conmieties does too, but more rapidly, and drops to 0 after 7. After 7 it becomes impossible to comply with the postulate that any 2 committees have a member in common. Number of elements, number of committees 1 8. Taking 6 points for example, 2 more committees become possible when the 6th point is added. At this time I was working on the material in the chapters on evolution and had drawn the 3 diagrams shown at the end of chapter 12, to represent 3 types of evolution. I then realized the 3 kinds of evolution were committees interrelationships between the powers of 3 kingdoms. Since there are 7 committees, and only 3 types of evolution, I had 4 triangles, or committees, unaccounted for. But the problem was simplified by the fact that having filled in the 3 evolutions, there was only one way to draw the remaining committees, keeping in mind that the first committee consisted of light, particles, and atoms, since this committee would come into existence first. The next committee, in addition to the 2 evolutions, is not possible until animals, and this committee interrelates cellular organization, animals, and height. I suspect it has to do with the introduction of choice into animals, and choice must have its origin in the free orientation which characterizes light. Surprising to me was the fact that I could not get a committee made up of plants, light, and molecules, which I thought would fit the storage of light by chlorophyll and hence be necessary to the plant kingdom. The 2 remaining committees which come into existence with the 7th kingdom are, 1. Dominion, form, and animation, and 2. Dominion, energy, and organization. Both seem to describe distinctly human activities, but I find them hard to distinguish. The animation of form suggests mechanical gadgets, but so does the organization of energy. So I will have to consider there is more to be discovered. However, the recognition of the cumulative factor uncovered more evidence for the uniqueness of 7. We have already noted the build-up of committees, which we will now call triads. Horizontal scale, number of elements. Vertical scale, number of triads possible for n elements. In addition to triads, it is possible to have tetrads, 4 element subsets. These must have no more than 2 elements, an edge, in common. As with triads, this requirement cannot be met with more than 7 elements. In the case of the tetrads, there is an even more rapid build-up. IZ3-3, P7. Adding up subsets of n elements, we have 1 2 number of elements 3 4 5 6 7 8 triads. Tetrads 0 0 0 0 1 to 12 4 0 113 7 7 0 0. Grand total of subsets 0 0 1 14 0. In short, then, the number 7 is unique in that it contains the maximum number of possible subsets, more than twice as many as any other number. It is also the largest number for which linked subsets are possible. The uniqueness of 7 is thus confirmed. There is no other number which has as many subsets. It is interesting also that while we do not at present know what these subsets mean or how they apply to practical questions, we believe them to be interactions between powers and hence important to the understanding of cosmology. Since the importance of subsets does not begin until the 5th kingdom or stage, this is the first kingdom to have 2 3-element subsets, we might suspect that one of these subsets had to do with evolution, because this is where evolution in the usual sense of survival of the fittest begins. However, this conclusion was reached independently in chapter 12. But why have subsets been overlooked in the exact sciences? I believe the question answers itself. The exact sciences cover only the first 4 kingdoms, in which the notion of subsets is not appropriate, since there is at most only one subset of each kind in a kingdom. We have thus confirmed, from considerations of the most abstract sort, the uniqueness of 7. The phase dimension * the usual equations of wave mechanics postulate flat space. I do not think that there is anything to be gained by trying to extend wave mechanics to curved space. Curvature and wave functions are alternative ways of representing distributions of energy and momentum, and it is probably bad policy to mix them. We have introduced the curved space of molar relativity theory as a mode of representation of the extraordinary fluctuation, and have obtained the fundamental relation, 3*8, between the microscopic constant A and the cosmological constants RQ, N. Having got what we want out of it, space curvature no longer interests us, and we return to flat space to pursue the specialized development of microscopic theory. That does not mean that henceforth we neglect curvature, we merely refrain from using the dodge that introduces it. The scale uncertainty, instead of being disguised as curvature, will be taken into account openly, so that there is no loss of rigor. Accordingly, the scale is now treated as an additional variate whose probability distribution is specified along with that of the ordinary momenta and coordinates. The variates of a probability distribution occur in conjugate pairs, and the variate conjugate to the scale will be called the phase. Since we have to provide for cases in which the scale reduces to an eigenvalue, the scale is classed as a momentum and the phase as a coordinate. The phase coordinate is represented as a fifth dimension normal to spacetime, which is now flat, so that the scale * from Eddington, Arthur Stanley. Fundamental Theory, pp. 46-47, London, Cambridge University Press, 1946. 283. And phase are invariant for the rotations and Lorentz transformations of special relativity theory. The scale uncertainty is primarily a fluctuation of the extraneous standard. But fluctuations of the standard are reflected in the measured characteristics of the system. The scale momentum is the measure of a characteristic which we may call the scale indicator. It is itself unvarying. But its measure shows these reflected fluctuations. In the ordinary momenta, the reflected fluctuations of the standard and the fluctuation of the characteristics themselves are inextricably combined, sp that we have to introduce one unvarying characteristic to exhibit the scale fluctuation by itself. We have employed a comparison particle to embody the extraneous standard, and have perfected the object system by including the comparison particle within it. The introduction of the scale and phase dimension is an equivalent way of perfecting the object system, and the scale indicator is the form taken by the comparison particle when it is brought into the object system. It is a common practice to use a six-dimensional space to represent a system of two particles. Here one of the particles is a comparison particle, and we need only to extend the object space by one dimension. Moreover, since the object system has always to be considered in conjunction with an extraneous standard, the extra dimension is a permanent feature of its representation. To represent the extraordinary fluctuation or cosmical curvature, the scale momentum must be given a Gaussian probability distribution with standard deviation O. For most purposes this would be a pedantic refinement, and the scale may be regarded as a stabilized characteristic. But now that each particle or small system has its own scale variate, a new field of phenomena is open to theoretical investigation, which is suppressed in the molar treatment of scale as an averaged characteristic. As remarked in 23, the comparison particle to be introduced into a microscopic object system is an individual, and the fluctuation of its energy is of order 1, in contrast to the mean comparison particle whose fluctuations are of order 10 registered. We have therefore to distinguish two steps: the substitution of an explicit, 5-dimensional, for a concealed. This is not the same as the fifth dimension introduced by curvature. In 6 the scale was represented by a distance OP in the u direction, but distances normal to spacetime now represent phase, the scale being a momentum. 285 I the phased Neuvian, curvature, representation of the mean scale, and in the explicit representation the substitution of individual scales for the mean scale. Since the mean scale is practically a stabilized scale, the second step is described as the destabilization of scale. For some purposes it is convenient to take an angular momentum as extraneous standard, so that the scale momentum is an angular momentum and the corresponding phase coordinate is an angle *. This facilitates the stabilization of scale, or rather it facilitates the destabilization of the fixed scale commonly assumed. The feature of an angular coordinate is that infinite uncertainty corresponds to uniform probability distribution between 0 and Ln-. Thus, if / is an angular momentum and 6 the corresponding angle, as the uncertainty of / diminishes, 6 tends to a uniform distribution over the range in and we pass without discontinuity from an almost exact, observed, value to an exact, stabilized, value of slash. Conversely, results which assume an exact scale are extended to a slightly fluctuating scale by spreading the distribution uniformly over a thickness ITT in an extra phase dimension. We call ITT the widening factor. From the widened distribution we can pass continuously to distributions in which the variation of scale becomes of serious importance. The widening factor must be taken into account when we compare spherical space, with stabilized scale, and flat space, with fluctuating scale. When the scale is stabilized we have a spherical space whose total volume is F equals Ln caret R caret O. Preparatory to destabilization this is to be reordered as a volume V3 equals Nr caret O of three-dimensional space having a thickness 4 in an extra phase dimension. Comparing it with a flat sphere of radius RQ and volume F4 equals 4/37 Ri, caret O, we have F3 equals 3/4 F4. Since V dash caret in natural units is a mass m, this is a relation of the form res equals 4/3 m4, and is an example of the law, 16-5, connecting ms's of different multiplicity. In V3 the scale is still exact and the phase necessarily has uniform distribution over the thickness Ln-, the representation does not. The complete momentum vector contains both linear and angular momentum, so that there is no incongruity in this choice. Give any extra freedom. In F4 the scale is destabilized and the constraint is relaxed, so that the number of degrees of freedom is raised from k equals 3 to k equals 4. Conversely, starting with the volume 4/3 caret q of flat space, we multiply it by a thickness 2 caret in the phase dimension, then multiply by March 4 to stabilize the scale since the stabilization reduces the number of degrees of freedom from 4 to 3, and so obtain the volume Ln caret R caret of scale stabilized space which is three-dimensional but curved. Index acceleration, 43, 44, 45 accident, 30, 105 acquired characteristics, 171 to 172 action as constant, 19 cycle of, 159, 266 principle of least, 16 to 18 quantum of, XXIV, 1, 14 to 16, 18 to 20, 22, 29, 58, 105, 150, 159, 253 to 254 Adam and Eve, 212, 214, 230, 233. 252 algebra, 54, 226 amino acids, 36, 75, 76, 78. Amoeba, 116, 119 Freud's analogy to soul, 136, 138, 140 locomotion of, 133, 135 to 136 Ampere, André Marie, 13 Anathema against Origen, 176 Angiosperms, 95, 106 to 108, 245 Angular momentum, 21 to 22, 25, 261 in Atom, 58 to 60 Animal Kingdom, XXII, XXIII, 1, 110 to 130 contrasted with man, 163 to 165 Evolution, XXII, XXIII, 163, 166 to 168, 178 to 179, 182. Flexible shape, 112 to 114 Group souls, 155 to 156, 172, 179 Instinct, 114, 152 to 157 Motivation, 110 to 111 Sacrifice of, 140 Substages, 119 to 128 symmetry, 38, 39 value scale, 114 to 115 voluntary movement, 110 to 111 animation, 95, 115, 202 Annelids, 124 anthropomorphism, 226 287 antimatter, 109 arc, the 8, 9, 42, 177, 195, 246 to 250, 251, 257 requirements for 45 to 46. Archetypes, 142, 143, 224 Aristo UE, 26 to 27, 176, 208, 248 Arthrophyta, 103 Arthropods, 74, 124, 125 to 127, 130 Astronomy, 204 to 206 Asymmetry, 17, 18, 39, 256 Atomic Kingdom, XXII, 1 to 4, 65 to 66, 117,118 Angular Momentum in, 58 to 60 Arc-like Descent of, 65 Bomb, 65, 83, 249 Construction of, 4 to 5 Degree of Freedom, 39, 56 N Periodic Table, 60 to 63. Shell Construction, 57 Substages of, 60 to 65, 118 Symmetry, 39 See also Molecular Kingdom Atomic Number, 4 to 5, 57 B. Bacon, Francis, 19, 23 3 N. Balmer, Johann Jacob, 58 Basil of Caesarea, Saint, 24, 26 to 27, 28 Beethoven, Ludwig van, 191 Bell, E. L, 192 Berkeley, George, 248 Besant, Annie, 173 Besetson, 143 to 144, 151. Bhagavad Gita, 177 Bible, the, 204, 206, 219 to 220, 233, 238 See also Genesis Big Bang Theory, 2. Billiard Ball Theory, 16, XXIV, 3, 5, 29, 90, 148, 254 Binding Principle, 69 Bird's Evolution of, 168 Navigation, 156 to 157 Blake, William, 25 Boer, Niels, 58 Bold, H, 97, 103 Boltzmann Statistics, 7 Bonds Covalent, 70, 73, 77, 81 Hydrogen, 76 Ionic, 72, 76, 77, 81, 82, 152 Molecular, 46 to 49, 159. Brain, Human, 39, 141 Evolution of, 168 to 169 Bridgman, p. 261 Breuil, Louis Victor de, 13, 58 Brunner, Oscar, 140 Buddha, 186, 203, 218 Budge, Sir Ernest, 210 Columnites, 124, 198 Canticles, 25 Carbon, 61, 64 Camelot, Nicholas Leonard City, 249 Castaneda, Carlos, 145, 203 Causality, 19, 149 Celestial Mechanics, Laplace, 25. Cell, the complexities of, 91 to 92 Differentiation, 97, 101, 120 Division, 1, 78, 91 to 93, 96 growth, 91 to 93 homogeneity, 95 to 96 central nervous system, 127 to 130 certainty, degrees of, 35 chakras, 197 charge, 10, 35, 143 to 144 chirality, 40 choice, 51, 52, 151, 178 to 179, 181, 207, 263 cha data, 109, 127 to 129, 130 Christ, 203, 218, 219 to 220, 230, 233, 252. Christianity, 176 to 177, 201, 243, 252 chromosomes, 78, 167 civilization, 182 to 189, 196, 243 clairvoyance and materialization, Gelii, 136 to 137 classification, 96 to 99 coelenterates, 120 to 122 collective unconscious, 223 combination, 82, 123, 124, 188, 189, 211,255,256 communism, 184 commutation, law of, 229 consciousness, 15, 159 control, 45, 51, 267 formal expression for, 43 to 44 Copernicus, Nicolaus, 3. Cosmic radiation, 167 to 168 cosmogony, XX, 226, 232 cosmology, 19 Coulomb's law, 54 covalent bonds, 70, 73, 77, 81 coward, Noel, 226 creative genius, 191 to 196, 199 to 200, 202 to 203, 213, 217 Cretan paradox, 1617 Crick, Francis, 78 Cronus, XX, 232, 233, 241 crystals, 34, 38, 39, 69 cybernetics, 43 CVCLES of action, 159, 266. Of learning, 51 to 52, 266 to 267 cytoplasm, 172 D Darwinian theory, 36, 167, 174, 242 De Vries, Hugo, 167 derivatives, position and, 43 to 44 determinism, 19, 7, 8, 9, 25, 26, 42, 48, 191,279 dimensions, 95 Dirac, p. A, 18, 54, 229 DNA, 19, 36, 78 to 84, 92, 93, 148, 152,153, 158, 171, 176, 179, 181. Dominion, XXIII, 79, 80, 82 to 83, 161 to 162, 165-166, 210-211, 255 of 182 to 206, 215, 216 to 220 double helix, B. Watson, 80 dreams, 133, 140 to 141 Dresden, NJ, 235 Durham, 141 ectoplasm, 134, 137 to 140, 145 Eddington, Sir Arthur Stanley, 14N, 25, 27, 49 to 51, 259, 261, 263, 265 to 267 Egyptian mythology, 231 to 232, 238, 241, 251 to 252 Einstein, Albert, 16, 14, 50, 260, 262. Electrical discharges, 36 electricity, 13 electromagnetic spectrum, 12 electron, 17, XXII, XXIII, 1, 4 to 5, 7, 11, 34, 35, 56 to 58, 66 embryophyta, 101 emlyn, T, 157 emotional projections, 141 to 142 energy, XXIII, 14 to 16, 19, 22, 58 to 60, 248,249 entropy, 46, 47, 48, 74, 90, 215 negative, 90, 95. Enzymes, 75, 76 Escherichia coli, 92, 94 ESPXX, 135, 145 ether, 13 to 14, 22 evolution animal, see animal kingdom bird, 168 brain, human, 168 to 169 cosmic radiation, 167 to 168 Darwinian, 36, 167, 174, 242 galactic, 83, 206 genetic, 170, 180 to 181 horse, 166 to 168 instinctive, 170, 178 to 179, 181 of man, XXIV, 158 to 161, 242 to 245, 250 molecular, see molecular kingdom. Mutation, 19, 167 to 168 plant, see plant kingdom specialization, 164, 167, 168 survival of the fittest, 93, 106, 159, 169, 282 versus involution, 90 to 91 I, the, 127 to 128 fall, the, descent into matter, 1 to 9 falsifiability, criterion of, 135 Faraday, Michael, 13 Fermat, Pierre de, 17 Fermi-Dirac statistics, 7 Fibonacci series, 112, 114. Fine structure constant, 6n, 35 first cause, 20 to 21, 26, 27, 45, 208, 252 Fisher, Bobby, 176 Fission, 65 Fork, the, 94 Form, 56, 112, 149, 172, 198, 203, 252, 255 Free will, 36, 48 Freedom, 131, 159 Degrees of, 38 39, 41, 42, 56 N, 77, 90 Loss of, 7, 34 Frequency, 14 to 16, 19. Freud, Sigmund, 136, 138, 140, 143,144, 149, 223 Function of Reason, B. Whitehead, 19 Fundamental Theory, Eddington, 50, 263, 266 Fungi, 108 to 109 Fusion, 65 G. Gaia, 232 to 234 Galactic Evolution, 83, 206 Galileo, 3, 191, 205 Galois, Fiverist, 191 Gardner, Martin, 113, 114 Gauss, Carl Friedrich, 192 Gellie, Gustav, 134, 136 to 137. Genesis, XX, 27, 33, 195, 198, 234, 240, 250, 252, 253 Genius, 191 to 196, 199 to 200, 202 to 203, 213,217 Geometry, XXI/I, 213, 259 7 Postulates of Projective, 267,269, 276 to 278 Goethe, Johann Wolfgang von, 191 Grant, Joan, 201,210 Gravitation, Theory of, 3, 25, 43, 54 Great Chain of Being, 245 Greek Civilization, 187 to 188 Greek Mythology, 232 to 234, 238. Green, Marjorie, 44 R.T. Gregory, Saint, 27 Grid, B, 84 to 85, 88, 193, 214 Chart of, 86 to 87 Myth and, 224 to 225, 229 to 230 Group Soul, 155 to 156, 170 to 173, 174,175, 179, 193 Growth, 65, 82, 91 to 93 Gulliver's Travels, Swift, 225 Gymnosperms, 104, 108 H. Handedness, 40 Heisenberg, Werner, 5, 6, 15, 25, 34, 40, 263 Helix, 74, 76, 77. Hemoglobin, 74, 75, 76 Heptavertins, 274 to 276, 278 Hertz, Heinrich, 13 Hexavertins, 273 Hierarchy, 90, 123, 209 to 210 Hindu Tradition, XX, 2, 176, 197, 201, 225 Hogarth, William, 18 Homer, 222 Horse, Evolution of, 166 to 168 Horus, 8, 201/1, 231, 232, 241, 251 to 252 Huygens, Christian, 12 Hydrocarbons, 71, 72, 82 Hydrogen, 4, 58, 63 to 64, 70. Bomb, 65 Bonds, 76 Hypersphere, 263, 266, 267 Identity, 94 to 95, 101, 112, 187, 214, 252 to 253 immortality, 179, 186, 217 to 220, 249, 253 Inca civilization, 184 to 185 individual soul, 175 to 177 individuation, 177, 182 to 183, 196, 256. Inert objects, 7, 29 inference, 19 infinity, 166 ingestion, 116 inheritance, 171 to 172, 193 instinct, 170, 178 to 179 animal, 114, 152 to 157 integral, theory of the, 201 introduction to mathematical philosophy, Russell, 16 invention, role of methodology, 19 involution, 91 ionic bonds, 72, 76, 77, 81, 82, 152 Iranian mythology, 234 to 236, 238 Isis, 8, 231,241,251. J. James, William, 144 Jung, Carl, 143, 223 K. Karma, Doctrine of, 186/J, 201 Kepler, Johannes, 3 Kiranii, Carl, 234 Kingdoms, 7, See Animal Kingdom, Atomic Kingdom, Dominion, Light, Molecular Kingdom, Nuclear Particles, Plant Kingdom Krishna, 203 Kundalini, 197 to 198 Kunz, Fritz, 37, 39 Lamarck, Jean-Baptiste, 171 Laplace, Pierre, 25 Laws, Scientific, 53 to 55, 132. Learning Cycle, 51 to 52, 266 to 267 Least Action, Principle of, 16 to 18, 193 Leibniz, Gottfried Wilhelm von, 18, 19, 83 Leonardo of Pisa, 112 levels, 4, 9, 32 to the power of fourth, 256 I, Light, Man, 35, 40 to 41, 54, 132 N, Particles, Animals, 35, 38 40, 54, 132 3, Atoms, Plants, 36, 39 to the power of 0, 54, 132 4, Molecules, 36 to 38, 54 to 55, 132. See also Animal Kingdom, Atomic Kingdom, Dominion, Light, Molecular Kingdom, Nuclear Particles, Plant Kingdom Light, XXIIXXIV, 1 Early Explanations of, 12 to 14 Enigma of, 10 to 11 Ether, 13 to 14, 22 as First Cause, 20 to 21 Frequency of, 11 to 12 Michelson and Morley Experiments, 14 Newton's Corpus Cleis, 12, 13, 22 Prescientific Concepts of, 24 to 28 Quanta of Action, 14 to 16, 22. Velocity, 10, 11 Wave Theory, 12 to 13 Linear Momentum, 21 to 22 Locke, John, 248 Logic, 1617 Logical Positivism, 248 M. Macrobius, 248 Magic, 203, 237 Magnetic Field XXI, 13 Mahatma Letters, XXII Man Animal in, 162 to 165 Dominion of, see Dominion Evolution of, XXIV, 158 to 161, 242 to 245, 250 Individual Soul, 175 to 177 specific problems of 159 to 160. Mapping, 269, 273 to 274. Murray, Eugene, 155, 156, 171, 185. Mass, XXIII, 35, 45, 249. Mast, C. Amoeba, locomotion of materialization of ectoplasm, 134, 137, 140. Mathematical theory of relativity, Eddington, 259. Matter, 1 to 9, 149 to 151. Maupertuis, Pierre Louis Moreau, 18. Maxwell, James Clerk, 13. Mayan mythology, 236 to 240. Mazda, 218. Mead, G. R.S., 222, 223. Mediums, 134, 137, 140, 149. Mendeleev, Dmitry, 60, 61. Mendel's law, 167. Medals, 68 to 69, 82, 148. Metamerization, 124, 130. Metamers, 198. Methane series, 36, 70 to 72. Michelson, Albert A., 14. Minerals, XXII. Mobility, 65, 75, 95, 104, 110, 120, 124, 126, 152, 168, 250, 255. Mobius strip, XXI/I, 273 to 274. Molar objects, 3, 6. Molecular bonds, 46 to 49, 159. Molecular kingdom, XXII, 1, 2, 3, 36, 6789, 117 to 118, 148. Correspondences on the arcade, 81 to 82. DNA, see DNA evolution in 7 to 8, 46, 79. Functional compounds, 72 to 73. Molecular kingdom, Kant, metals, 68 to 69. Methane series, 70 to 72. Polymers, 73 to 74. Proteins, 74 to 78, 79. Salts, 69, 148. Substages, 67 to 81. Symmetry, 37 to 38, 39. Monad, 46, 48, 160, 200, 247, 252. Morality, 214 to 216. Morley, Edward Williams, 14. Moth navigation, 135, 155. Motivation, 110 to 111, 133 to 136. Mozart, Wolfgang Amadeus, 191. Muscles, 74, 75, 149, 150. Mutation, 19. De Vries theory of 167 to 168. Myth, 8 to 9, 221 to 241, 254. Egyptian, 231 to 232, 238, 241, 251,252. Freudian interpretation, 223. Greek, 232 to 234, 238. Grid and 224 to 225, 229 to 230. Iranian, 234 to 236, 238. Jungian interpretation, 223 to 224. Mayan, 236 to 240. Old interpretations, 222 to 223. 7 stages, 233 to 241 N. Napoleon I, Emperor, 191 Nature, 245 Nature of the physical world, the Eddington, 261 Necessity, 30 Negative entropy, 90, 95 Nervous system, Central, 127 to 130 Neutrino, LLN Neutron, 57, 83 Newlands, 60, 61 Newton, Sir Isaac, 3, 22, 25, 43, 191, 205, 260 Newton Sleep, 25 Nitrogen, 64 Northrop, J. H, 6 N Nothingness, 166 Nuclear Particles, XXIII, 35, 40, 95 Electron, 18, XXII, XXIII, 1, 45, 7, 11. 34, 35, 56 to 58, 66 Neutron, 57, 83 Proton, XXII, XXIII, 4 to 5, 35, 56 to 58, 66, 118 Nucleation, 142 to 144 Obelia, 115, 190 Objectivity, 188, 279 On Growth and Form, Thompson, 37 Oppenheimer, Robert, 26 Organization, 122, 255 Cellular, 92 to 93 Levels of, 2, 169 Molecular, 8 Orpheus, 203, 218 Osiris, 8 to 9, 201 N, 218. 231, 232, 240. 241,251 to 252 Oxygen, 4, 64 Pascal, Blaze, 191, 272 Patton, George, 176 Pauli Exclusion Principle, 108 Pauling, Linus, 75 Pentavertons, 272 Periodic Table, XXIII, 60 to 63 Personality, Transcendence of, 198 to 199 Phase, 263, 283 to 285 Phase Dimension, 49 to 52, 151, 263, 283,286 Phosphorus, 64 Photoelectric Effect, 14 Photography, 14 Photon, XXIII, 1, 11, 14, 22, 35, 105, 118. 148, 250 Photosynthesis, 115 Planck, Max, XXIV, 14 to 16, 18, 27, 28, 83 Pizarro, Francisco, 184 to 185 Plant Kingdom, XXII, 1, 90 to 109, 115, 117 Degree of Freedom, 38 Fungi and Retrogressive Stages, 108,109 Reproduction, 95, 101, 105, 194 Substages of, 96 to 104 Tissue Layers, 107 to 109 Plato, 2, 176, 248 Play, 30 Plisner, Helmuth, 44 N. Plutarch, 222 to 223 Pollution, 189 Polyhedrons, 272 Polymers, 46, 73 to 74, 76, 82, 90, 124, 148, 198 Polyvertons, 269 to 274 Populva, 236 to 237, 241 Position, 43 to 44, 111 positionality, 44 n positron, 18, 54 potential, 255 precognition, 146 predictability, 5 to 7, 147 Price, Charles, 67 Prince, Raymond, 136, 143 probability Fogg, 7, 208 process, theory of, 1719. Brief outline of, 255 to 258 comparison with classical physics, 53 cumulative nature of, 1 to 2. Process, Kant, as described in Myth, XX, 221 to 241 levels of descent, 34 to 36 periodic table, 60 to 63 purposiveness in, 32 to 33 7 stages of, XXXXIV projectiveness, 133 proteins, 36, 74 to 78, 79, 82 proton, XXII, XXIII, 4 to 5, 7, 35, 56 to 58, 66, 118 pseudopods, 135 to 136, 139 to 140, 145, 149, 150 Psyche, X, 136,138, 140,141 Psychic energy, 142, 143, 172. Psychic healing, 134, 139 Psychic projection, 145 Psychic protoplasm, 136 to 139 Psychometry, 203 Psychotherapy, 143 Purposiveness, 19, 23, 32 to 33, 104 to 106, 207 Pythagorean tradition, 5, 58, 248 Quanta of action, XXIV, 1, 14 to 16, 18 to 20, 22, 29, 58, 105, 150, 159, 253 to 254 Quantum physics, XXIV, 1, 3, 15, 26, 28, 29, 33, 148, 253 to 254, 265. Quantum theory, 14 to 16, 48, 159, 229, 261 to 264 Quantum of uncertainty, 29 to 30 R radiation, 15 to 16, 58 Rationality, 279 Ratios, combining, for reason, 27, 187, 203 to 206, 211 Rebirth, 230 Riser, Oliver, 96 Relativity, Theory of, 16, 49, 259 to 261, 263 to 265, 267, 283 Reproduction, 95, 101, 105, 194 Revealed Religion, 26 to 28, 60, 243, 244, 254. RNA, 79, 92 Rotation, 260 Russell, Bertrand, 16, 260 Rutherford K. Ernest, 4 Sacrifice, 134, 139 Animal, 140 Carat Human, 185 to 186 Salts, 69, 148 Scale, 51,283 to 286 Schrank von Notzing, A. P.F. Baron, 134, 137 Schrödinger, Erwin, 58 Science, 1516, 19, 53 to 55, 132, 188,189, 191,212 to 213,221 scientist, roll of, 19 selection, process of, 93 to 94. Self-determination, 184, 186, 188, 201, 210 to 214, 252 self-limitation, 94, 194 self-transcendence, 245 sensory deprivation experiments, 141 separate reality, A. Castaneda, 145 set, 8, 20 ln, 231, 241, 251 to 252 7 s, xx, 259 to 282 Shakespeare, William, 191 shape, flexible, 112 to 114 Sheldon Williams, I. P. 24, 27 silicon, 64 Sinnott, Alfred Percy, XXII Smith, Harry, XXI. Sodium, 64 Sol, 247 to 250, 251,253 Group, 155 to 156, 170 to 173, 174 to 175, 179, 193 individual, 175 to 177 Soul of the White Ant, the, Murray, 155 space, 10 curvature of, 50, 260, 264, 265, 283 specialization, 164, 167, 168, 174 spirit, 161, 203, 208, 247 to 250, 251 structure, theory of, 1617, 33 substages of animal kingdom, 119 to 128. Of atomic kingdom, 60 to 65, 118 of dominion, 182 to 206, 215, 216 to 220 the grid, 84 to 88 of molecular kingdom, 67 to 81 of plant kingdom, 96 to 104 substance, 64, 95, 138, 142, 172, 203, 248, 255 sulfur, 64 summation convention, 259 to 260 survival of the fittest, 93, 106, 159, 169, 282 Swift, Jonathan, 225 symbols, language of, 224, 225 to 229. Symmetry, XXIII, 33, 79 bilateral, 38, 40 complete, 38 of descent and ascent, 37 to 41 as deterioration of artistic style, 8 Exine radial, 38, 90s and Gyurgy, Albert, 75 Tachyons, 28 Teilhard de Chardin, Pierre, 195 Teleology, 18, 83, 166, 250 to 253. Telepathy, 146 Temperature, 15 to 16, 36, 47, 48 Termite colonies, 155 to 156, 171, 185 Tetrahedron, 270, 272, 273 Theosophy, 183 Thermodynamics, Second Law of, 74, 90 Thompson, Darcy, 37 Time, 1618, 95, 181 asymmetry, 17 one-wayness, 17, 18 timing, 48 to 49, 263 tits, British birds, 157 topology, XXI, 259 Taurus, XXIXXII, 262 to 266, 278 transformation, 116. Turn, the, C arc, the U ultraviolet catastrophe, 15 uncertainty, 5 to 7, 25, 50, 111, 159, 221, 253, 263, 264 unconscious, 141 unified field theory, 50 Uranus, 232 to 234, 241 value judgments, 110 values, 181 Veblen, Oswald, 259 to 260, 267 to 268, 276, 277 Vegetable Kingdom, Sea Plant Kingdom Velocity, 10, 11,43,44, 111 Virus, 80 Volta, Alessandro, 13. W. Watson, James, 78, 80 Wave Equations, 58 Wave Mechanics, 283 Wave Theory of Light 12 to 13 Whitehead, Alfred North, 19, 96 Wholeness, 19 to 20, 23, 59, 105 Will, 36, 48, 149 to 151 Willoughby, David P., 199 to 200 Yoga, 129, 197 Young, John W., 267 to 268, 276, 277 Zen Buddhism Paradox, 10 to 11 Philosophy, 26, 241 Zeno, 43. Zeus, 232, 233, 241 Zoroaster, 203. The author Arthur M. Young, inventor of the Bell helicopter, graduated in mathematics from Princeton University in 1927. In the 30s he engaged in private research on the helicopter, and in 1941 he assigned his patents to Bell Aircraft and worked with this firm to develop his invention. In 1952 he created the Foundation for the Study of Consciousness. This foundation, dedicated to the integration of scientific thought and research into the nature of consciousness, has published a journal, and runs a teaching institute. The Institute for the Study of Consciousness. With Charles Muses, Arthur Young is the editor of Consciousness and Reality, Outerbridge and Lazard, 1972. The work of Arthur M. Young. We are fortunate to have in Arthur Young a man of real knowledge. He is someone who has begun to show the relationships between physics and metaphysics, between expanded human consciousness and direct perception of cosmic structure. Gay Geerloos, Ph.D., author of Body Time. The Reflexive Universe is an extraordinary and fascinating work. A breathtaking experience. Colin Wilson, author of The Outsider. As Copernicus initiated a profound transformation of the ancient world, this paradigm establishes the basis of a science of consciousness with implications of comparable magnitude. Kenneth R. Pelletier, Ph.D., clinical psychologist, University of California. Arthur Young's work has successfully established a foundation where Western technology and Eastern philosophy meet. Tarthang Tulkarinpoche, Head Lama, Nyingma Institute. Arthur Young has built an edifice of the mind in which his timbers have been the great concepts of thought, the action principle of modern physics, the DNA of organic chemistry, the species differ. Initiation of biology, the haunting insights of ancient myths, the topological power of the toroid. A lifetime of reflection by one of the most eclectic and penetrating minds of our time. David Lawrence Hill, nuclear physicist in the reflexive universe, Arthur Young reveals his new intuitive insights into the great myths of mankind, as well as into the freshly minted facts and theories of modern science. For the rapidly evolving person searching for a bridge between old knowledge and new knowledge, this book provides a new path. J_Andrija Puharic, author of Yuri Delacorte Press / Seymour Lawrence ISBN 0-440-05924-0 printed in USA.